The dawn of 2035 is set to mark a definitive pivot in the balance of power within the West Pacific, as the era of fifth-generation stealth fighters yields to the unprecedented capabilities of sixth-generation air supremacy platforms. At the heart of this transformation lies a high-stakes technological race between the Global Combat Air Program, a trilateral endeavor led by Japan, the United Kingdom, and Italy, and the burgeoning shadow of China's next-generation interceptor, tentatively identified as the J-50. For Japan, this is not merely an exercise in military modernization, it represents a fundamental restoration of national engineering sovereignty and a strategic necessity to secure its vast maritime boundaries against an increasingly sophisticated adversary. The fiscal commitment reflected in Japan's defense budget for the 2026 fiscal year, which exceeds 9 trillion Japanese yen, underscores the gravity of this mission. This budget, equivalent to approximately 60 billion United States dollars, allocates substantial resources to ensure that the Global Combat Air Program remains on a trajectory to achieve operational readiness by the middle of the next decade. The urgency underpinning Japan's pursuit of the Global Combat Air Program is exacerbated by the rapid advancements observed in the Chinese aerospace sector. Intelligence reports and satellite imagery from late 2025 suggest that China's J-50 program is advancing at an accelerated pace, with a primary objective of achieving initial operating capability as early as 2030. The J-50 is characterized by a tailless delta-wing design, a configuration that optimizes multi-spectral stealth and reduces the radar cross-section across a broader range of frequencies. Unlike traditional stealth aircraft, this design minimizes infrared signatures and enhances aerodynamic efficiency for sustained supersonic cruising without the use of afterburners. For the Japan Air Self-Defense Force, the emergence of such a platform in the hands of the People's Liberation Army Air Force poses a direct threat to the traditional qualitative edge that Tokyo has long maintained. The prospect of an adversary possessing a platform that can bypass existing radar networks and engage targets with ultra-long-range missiles like the PL-21 necessitates a response that is not just iterative, but revolutionary. In response to this shifting landscape, the Global Combat Air Program serves as Japan's technological vanguard. The collaboration between Mitsubishi Heavy Industries, BAE Systems, and Leonardo represents a synergy of Western and Eastern aerospace excellence. A critical component of this project is the shift toward a system of systems philosophy. The sixth-generation fighter will not act as a solitary hunter, but as the central node of a vast interconnected network. This involves the integration of collaborative combat aircraft, or loyal wingmen, autonomous drones capable of performing reconnaissance, electronic warfare, and kinetic strikes ahead of the manned platform. By 2026, Japan's investment in these unmanned systems is expected to surpass 100 billion Japanese yen, reflecting a strategic shift toward minimizing pilot risk while maximizing battlefield persistence. The ability of the Global Combat Air Program fighter to command a swarm of drones allows for a distributed lethality that the J-50, focused more on individual stealth and speed, may struggle to counter in a high-intensity environment. Technological pride, a cornerstone of the Japanese industrial identity, is most evident in the development of the aircraft's sensory and propulsion systems. Mitsubishi Electric is currently spearheading the creation of a next-generation radar system utilizing gallium nitride technology. This system is projected to possess a data processing capacity 10,000 times greater than current radar systems equipped on the F-35. In an era where stealth is becoming a baseline requirement, the ability to process massive amounts of environmental data and detect minute anomalies becomes the ultimate decider of aerial combat. This integrated sensing and non-kinetic effects suite will allow the Global Combat Air Program fighter to act as a flying data center, identifying and jamming enemy communications while remaining invisible to their sensors. Simultaneously, the collaboration between IHI Corporation and Rolls-Royce on the engine platform focuses on high-temperature materials and additive manufacturing. These engines are designed not only for thrust, but for immense electrical power generation, which is essential for fueling the high-energy laser weapons and advanced electronic warfare suites that will define the 2030s. Furthermore, the Global Combat Air Program represents a historic departure from Japan's decades-long reliance on United States aerospace technology. For years, the Japan Air Self-Defense Force operated under the constraints of black box technology, where critical software and hardware components of American-made aircraft, like the F-35, were off-limits to Japanese engineers for modification or repair. The Global Combat Air Program restores what strategists call the freedom of modification. By co-developing the source code and hardware architecture, Japan ensures it can independently upgrade its fleet to meet specific regional threats without awaiting foreign approval. This sovereign capability is managed through the newly established GCAP International Government Organization, headquartered in the United Kingdom, but with significant Japanese leadership. This organizational structure ensures that the interests of the Japanese defense industry, represented by the Japan Advanced Intelligence and Electronics Complex, are protected and that the economic benefits of the project, estimated to involve hundreds of domestic suppliers, flow back into the national economy. The industrial impact of this program extends beyond the battlefield. The revitalization of Japan's aerospace sector is expected to create thousands of high-tech jobs and foster innovations in materials science and artificial intelligence that will permeate the civilian sector. The strategic narrative for the Japanese audience is one of shokunin spirit, the pursuit of perfection through craftsmanship, applied to the most complex machine ever built. It is a story of a nation reclaiming its position at the forefront of global aviation. As the J-50 program moves toward mass production in the early 2030s, the Global Combat Air Program must navigate the delicate balance between technological ambition and the rigid timelines of the 2035 deadline. The success of this program is not just a matter of military procurement. It is the linchpin of Japan's broader, proactive contribution to peace strategy, ensuring that the skies of the West Pacific remain open and that the balance of power does not tilt irretrievably toward a single hegemonic force. In conclusion, the competition between the Global Combat Air Program and the J-50 is the defining arms race of the 21st century. For the Japanese observer, the stakes could not be higher. The project embodies the convergence of national security, industrial sovereignty, and technological excellence. While the challenges of cost and international coordination remain, the progress made by early 2026 suggests that Japan is well positioned to field a platform that transcends the limitations of current aerial warfare. By integrating advanced sensing, autonomous wingmen, and sovereign software, the Global Combat Air Program ensures that the Japan Air Self-Defense Force remains a formidable deterrent. The future of the Indo-Pacific will be decided by the engineers in Nagoya, Wharton, and Turin, whose work today determines who will command the high ground of tomorrow. As the 2035 horizon approaches, the Global Combat Air Program stands as a testament to Japan's resolve to defend its sovereignty through innovation and international partnership.